the most miserable? Right. Yeah, this dude that sits behind me in the choir at church was singing that the other day, and it just kind of stuck. It's the most miserable.
Do you not like Christmas country?
No, I like it, but I just think it's a funny song to sing. Because everybody's like, what? I'm good with Christmas, but it's just funny because then everybody's like, oh my gosh, she's a Scrooge. Okay, going to start off, we are adding and subtracting today, and I told you yesterday, adding and subtracting, in my opinion, is a little bit more difficult because you got to get a common denominator if you don't have one. But I've started you off here with a common denominator. So these are the easy ones. When your denominator is the same, we got a 9 and a 9 on bottom. So just like when we were little tots and those were all numbers, the 9, since it's common, the 9 will be the denominator of my answer. And then I just combine like terms of the numerator if I can. On this one, 7x plus y, I can't combine that. So it just stays as 7x plus y. So that's all you would have to do. Pretty simple to start off with on that. So if I have 8 over 3x cubed minus 14 over 3x cubed. Okay, subtraction sign this time. So first thing you got to ask yourself is there a common denominator?
Yeah.
Yep, so we're good. So since the denominator is common, 3x cubed, that's going to be my answer denominator. Now I can actually combine these. What's 8 minus 14? Negative 6. Good job. Don't circle that one. What can you now do to that? Good. The negative 6 over 3 reduces. So negative 6 over 3 is the same as negative 2. That's it. So you reduce them when you can. Now remember yesterday when we were doing the ninja math stuff, if it's a binomial or a trinomial, you can't pick it apart. But that thing where the negative 6 is, that's a monomial, so you can always reduce monomials. Yippee, yippee, yippee. Alrighty. Here I've got, let's do this one, r over r squared minus t squared plus t over r squared minus t squared. Alright, so we'll start off just like we just did today, but then it's going to connect to yesterday's lesson. So today-wise, it's an addition problem. Do I have a common denominator? Yep. So my denominator will be r squared minus t squared. And then on the top, what's r plus t? R plus t, that's exactly right, ma'am. Now, yesterday, then, if that could simplify, we did. And I can't mark anything out like it is because those are binomials, but that binomial on the bottom can factor. How does the binomial on the bottom factor? It's like the bell ringer. Good, it's difference of squares. So the top is going to say r plus t. The bottom, square root both of those. One gets a plus, one gets a minus. Difference of squares. R minus t. So then it's ninja time. What's left on top if I marked everything out? 1. Good job. There's your final. There's your final.
How do we know if we're going to take semester test?
Well, it has to do with your absences and your grades. So you can miss 4 days if you have an A. You can miss 3 days if you have a B. And you can miss 2 days if you have a C. Also, a lot of y'all will not be exempt because you have more than 4 tardies. That counts too.
That's me.
Yep. I don't know.
Do you have more than 4 tardies? You have to take semester test?
According to the handbook.
Yeah.
I thought it was 2.
I did too. At one point I told somebody that, but the office sent me an email said it's 4. 2 is what gets you D-Hall.
Yeah. I'm lucky here. It's already open. That's retention.
Alright, let's look at where we don't have a common denominator now. Oh no, this is getting good. Start off easy on this one. Alright, I got 6 over m plus 1 over 4m.
Ours is got 4.
Oh.
Alright, so we don't have a common denominator. Right? One of them's an m, one of them's a 4m. So I'm looking here, what do m and 4m both go evenly into?
Oh.
Well, they both already have an m, yeah. But what about the 4?
Yeah.
It had to be a 4m, wouldn't it?
Right.
So you multiply that by
Mhm. So I'm going to make my common denominator. I always show my steps like that. So when I'm looking here with the 6, it already had the m. The new thing I multiplied down here was 4. So I have to also multiply the top by 4. Over here on the 1, it already had the 4 times m, so I don't change it at all. Just bring that down. Okay, now I've got 2 like the problems we started off with. 4m is my common denominator, so it's going to be my answer's denominator. 24 plus 1.
185.
Won't reduce, that's it. Alright, I want you to try one like that before we get to some that have got binomials in them. Make out what you do on that one?
How'd you get that?
I'll be in my notebook and it's great.
Alright, I got 5 over 2p plus 3 over 8p. See if you can figure that one out. Go.
Me and Blake won a board race.
Oh, goodness.
That's right.
The Friday before we got out for Thanksgiving, that technology assistant dude was in here working on my smart board, and he decided that it was what I told him was wrong in July. And he said he'd be back Monday after the break to fix it.
Did he fix it?
No.
Girl,
No.
you should fire him.
What's wrong with it?
The wire is bad.
What if
Me
you're
and my job.
Alright, you ready? What's your common denominator? What will 2p and 8p both go evenly into? 8p, very good. A lot of times people will say 2p, you're not looking for the factor, you're looking what they'll go into, so it's usually the bigger. So I'm going to have 8p's on both of them. Okay, 2p times what would get me the 8p? 4, so I got to multiply the top by 4. That's a 20. This one already had an 8p, so don't change the 3. That's just 23 over 8p. How'd you do?
Blake got it wrong.
Blake.
Does that for all the time. I
2 over y minus 1 over y plus 4. Okay, we stretched it a step here because the term on the right has a binomial on the bottom. We're eventually going to get to binomials and trinomials on both of them. Good. If I'm looking here, and this is like if, for example, if I was doing 2/3 minus 1/2, okay, just for pretend 2/3 minus 1/2, I know that denominator 6. Where did that come from? 3 times 2, right? So it's the same thing here. I'm going to just multiply those to get the common denominator. But I'm going to leave it as y times y plus 4. Just like we would do over here when we were little tots with 3 times 2. So then this one will also be y times y plus 4. Now you could distribute that y out, but I don't like to, and that's just my personal preference. The reason I don't like to distribute it is because when I've got it written in pieces, I can see which piece it already has, so I know what to give to it. You know what I mean?
Yeah.
Alright, so on this 2, it already had the y, so it's the y plus 4 that I have to distribute the 2 to. Right? So that would make 2y plus 8. You follow that? We distributed a 2 to the y and a 2 to the 4. Okay, on this one, it already had the y plus 4, so it's just the y that I need to multiply the top by. So 1 times y is just y.
Why would it be y plus 8?
I distributed 2 to that. No, not all the way. But you're going to combine, subtract them. What happened to my 4 where?
On the 17.
I skipped a step. I shouldn't have done that. I had 2 times y plus 4. So that got me the 2y plus 8.
No, not on that side, on the other side.
It already had y plus 4,
Oh, okay.
so y was its new piece. Good, Louise? Alright, so now we've got a common denominator. So my answer is going to have y times y plus 4. And on the top, there's actually some like terms up there. You've got 2y minus 1y, which is just a 1y. Good. And then you've still got plus 8. Now, if I had anything to ninja from there, I would. So, can you ninja anything? No, that's it. That's good. Plus 8 and plus 4 is not the same, so you can't ninja those. Alright, here we got what we need on that one? Here we got 2 over x minus 2 minus x plus 3 over x minus 1. Alright, got a little bit more complicated up because we got binomials on both denominators. Is my denominator the same on both of them? No, I mean that should be obvious to you. So, just like before, what's my common denominator going to be? The product of those two. So my denominator is going to be x minus 2 times x minus 1. I'm going to put that on both sides. Alright, try not to skip any steps this time. The 2, it already had an x minus 2. So what new piece did I multiply on bottom? X minus 1. So I'm going to take that 2 and I'm going to multiply it by x minus 1. You can go ahead and distribute it if you want to, but I didn't want to I confused people last time when I did that. Over here on the x plus 3, it already had the x minus 1. So what new piece did it get? X minus 2. So I got to take that top and multiply it by x minus 2. Okay? So now, some of y'all have already done it. Now I've got to do some distributing and foiling on top. This will get me 2x minus 2. This one, we'll do it out by the denominator. X squared minus 2x and plus 3x is plus x, and then minus 6. No, and that's a good question though, because what Kelsey was talking about is a pretty legitimate question. Right here it looks like I could ninja, right? Can't ninja unless we're multiply, divide, or an equal sign. You can't ninja with the minus, plus or minus on there. Now, hopefully in the end we'll be able to, but not quite yet. All right, so now where we're 2 down there, we're looking for like terms to combine. Bump that up so we can see it. Well, yeah, let me write my denominator, x minus 2 times x minus 1. Alright, on the top, I'm going to put it in standard form, so I'm going to put the x squared first, but there's not an x squared over here, and that's a minus sign. So that's like 0 minus x squared. So it'll be negative x squared. Good. 2x minus x. Just x. Negative 2 minus negative 6. 4. Positive 4. Okay. We've got something ugly looking there. So what I like to do next is to factor that numerator to see if I can ninja anything. But with that negative x squared, nah, that's just no good for me. But go ahead and use some common sense and think about it. Even if we took a negative out to change all that, your a times c would be 4, right? Down here, in order to ninja anything out, I'm going to have a negative 2 and a negative 1. So it's possible that you could get a negative 2 somehow out of that. But on the top, is there any factors of 4 that can make a 1 in any way? No, you got 2 and 2 and 1 and 4. So I'm not going to be able to get that 1 in any way, am I? So it's not going to do me any good because I won't be able to ninja anything. That's it. Alright, let's look at this thing. This is got 3 parts. Alright, we got 3 pieces on this one. We're going to work just left to right, just like we would if they were Plano numbers, because addition and subtraction are equal in the order of operations. It just goes left to right. But I got to get a common denominator. Now, if you look at the first 2, if we just put your hand over that last one, over that negative 10 piece, and just look at the first 2. The product of it would be x times x minus 5, wouldn't it? What is the denominator of this? It's the same thing. Katie saw that. Do y'all see it? If I were to distribute this, x squared minus 5x, right? So my denominator is going to be, and you can write, I'm going to write it as x times x minus 5, but over here, it's the same thing. Everybody okay on that? Took an x out of that last piece, it's the same thing. Okay, so the 4 already had an x minus 5. Its new piece on the bottom is an x. So we got to multiply the top by x, so 4 times x. Now the negative 2 already had the x. Its new piece on bottom is x minus 5. So we got to multiply the top by x minus 5. Okay, what new piece did we give this? Nothing, so we don't change the 10. We wrote it different, or I wrote it different, but I didn't change it, so I don't change the 10. Okay, we all right?
Did you factor that out? I'm not going to do that one. Distribute it.
Yes, that's what I'm fixing to do right now, because then I'll have like terms to combine. All right, so this gets me 4x. I'll go ahead and write the denominator again. Then I'm fixing to distribute this negative 2 here, so I've got, I don't know what sign to write to not confuse you. I'll just go ahead and keep the plus sign there. And that'll make that negative 2x and positive 10. Alright. So left to right. 4x, it's just like terms. 4x plus negative 2x is 2x. And then I've got a 10 and a negative 10. That cancels out, right? So all I've got left on the top is 2x. And then on the bottom, there's still my denominator. Now, you can simplify that one more step. What can you do to simplify that one more step? Good. You see that, Angie? Mark those x's out. So you just got 2 over x minus 5. Alright, the hardest time we're going to see today. You ready? What? Yeah, you better.
It's gonna be long.
Alright, we got 4 over p squared minus 6p plus 9 plus 1 over p squared plus 2p minus 15. Okay, so we went to both trinomials. That's what the initial extra stuff is. And it's not a common denominator.
Negative.
Yes.
Unless
Bailey said, do I need to factor it? And I said, yes. I'm going to factor it to see what pieces they both have. Then that way I can see what new pieces to give to both of them. So here on this one, what factors of 9 add to negative 6? So that'd be, good job. Good job, all right. What about on the other side? What factors of negative 15 add to positive 2?
5 and -3.
Good. All right. Now, when we look for our common denominator, if it's on one of the denominators, it's got to be part of our common denominator. So this side has got p minus 3 twice. So p minus 3 twice has to be part of my common denominator. This side, we've already covered that p minus 3, but it's also got a p plus 5. So p plus 5 is going to have to be in my common denominator. Okay. Alright, so we ready to see what we need, new stuff we need on the 4? Here with the 4, it already had the p minus 3 twice. What new thing is down here? So we multiply the 4 times p plus 5. On the 1, it had the p plus 5, and it had one of the p minus 3s.
So you just do 1 p minus 3.
So it's going to get a p minus 3. Good. Okay, now we're ready to distribute and then combine like terms. So that wasn't too bad.
4 p plus 17.
Austin's right. Everybody with him?
Hold on, wait, what?
4p plus 1p
Oh, okay,
is 5p. 20 plus negative 3,
so 17.
17.
So your denominator always does something.
Yeah, sure it's not good. We've been doing it all class year.
No, but I'm just honest.
Okay,
Yeah,
I
keep him
do
afraid.
have a question
They
though.
never give you.
Why would I need p minus 3 squared?
Because there's 3 of them. That's all.
Let's do another one.
We're fixing to. Hold on, I gotta try to answer a question. That's okay.
Because there's 3.
Yeah, I get that.
I don't know. I just
Yeah, where is it squared? Is it squared because
Because there's yes.
or is it because it's on both sides?
No, it's because there's 2. The square came because there was 2.
But what happens to the others?
Well, these 2 cover that. Like, let's say we had 2 6 and 1/3. gonna multiply by 2, but you don't have to here because it already had a 3 with it. It's just hidden. So if it's just the most that they got on one side.
Okay.
Scott, did that get? Are you good? All right, we're gonna do another one. We got 3 over x squared minus 5x plus 6 minus 2 over x squared minus 4x plus 4.
Right.
Hey,
Do you have any members of the Spark Top Club?
2 raised their hand.
Okay, can you send them to the office?
Okay.
Thank you.
What club is that?
It's like the special ed club we held in.
Alright. On, they're going to find a common denominator. So can I factor any of that stuff? Yep, you can factor them both. On the left. Thank you, Austin. What?
6 and -1.
No, that doesn't add to -5.
Negative
-2 and -3. Good. Okay, what about over here? Okay.
Multiply the right by x minus 3 multiply the left by x minus 2.
Blake's right. I was just waiting to let everybody get caught up. Alright, now Blake just told me what I'm going to multiply both sides by. He's right, and I can do that, and that's great. Some of y'all are writing the whole denominator down still, which I would recommend while you're still a little confused. So if Blake said I'm going to multiply this left side by x minus 2, what's the common denominator?
X minus 3, 2,
Not-
squared.
Good. Good. So let me get that written on both sides. Okay. Because over here we had 2 of them.
Yeah, I see that. But why
Yes, sir. And if you don't like the squared, you can write it out twice.
Yeah, I'm squared.
Alright, so here with the 3, it already had one x minus 2 and an x minus 3, so it needs another x minus 2. Here with the 2, it had both of the x minus 2s, so it needs the x minus 3. Okay, so get ready to distribute. 3x minus 6. 2x minus 6. Alright, now we're subtracting like terms. So 3x minus 2x is 1x. Negative 6 minus negative 6. 0.
There's a lot.
Yep. That'd be it. Good job.
I said everybody in the room gonna come out to this Some people like to lie if they're in the club, and everybody come outside like they're in the club. They don't even come to the meeting.
You're saying that like you live in the hood.
I talk like that sometimes, and I'm like, you're white.
Alright, let's try one more.
thought that was around.
I didn't say that.
Yeah, you did.
I just did
You agreed with me.
Don't work it out this time, let me finish.
Okay. Yeah. Yeah.
But I like to have this one.
Well, that I beat you. Duh. If I do it in your head, I gotta write that down.
No, it's right.
Bless you.
See, I'm not.
Yeah, because you're going to start. That's no fair.
Alright, see if you can get that one. Go. We just factored that first one. It's the same.
Got it, Coach.
I had a kid, Blake.
Oh, I did the math. Unless you counted wrong.
No. The number
There was a 10 difference. Oh, I have 10 less. Then why would you want to do that?
because all the words on my papers are easy. They're like Henry Ford and
You know, if we report on Henry Ford in the 3rd grade, I should be Henry Ford. I love Henry Ford is
It's the most miserable time.
what are you laughing at? Show me. I have a Henry Ford scrap. It's so weird. Oh my, it's like running. Yeah, sure. I have a can on Thomas Jefferson. This is the class that we did.
Wait, you-
Wait.
It was Thomas Jefferson. Who even likes Thomas Jefferson? It's some old guy. There's some old guy in one of my friends on my family that he likes to go skiing.
Alright, I think I may have got it right. I don't think so.
Your mom is I know. I don't know. Again? Why not just put X minus 2? That's what I've been doing. I've been pretty spread out.
I didn't know you were working.
No.
If I tried to do this, that'd be wrong.
So you're taking
If you're stuck, if you're spinning your wheels, all I've done is factored and got my common denominator. I haven't done anything else. So check and see if your factors are right and your common denominator's right. Were you with me so far before I quit? Hey, Reed.
I stood up all night. And she was like, are you going to get your homework? And I was like, not a chance. And then she was like, oh.
Alright, we alright to where I am? You need a second to finish it? Okay, the 2 on the left, the 2 already had the x minus 2 twice. It was missing the x plus 3. The 3 had one of each, so it needs another x minus 2. Okay, distribute the 2 over there. That gets me a 2x plus 6. Distribute the 3 there. That gets me a 3x minus 6. Very similar to the last one, but this one's an addition problem. So 2x plus 3x is 5x. 6 plus negative 6 is nothing. That's it.
Like I got it right.
Good job. Stressed him out, Blake. Alright. Tomorrow's stuff, it's called complex fractions. It gets to a fraction within a fraction. A little bit more difficult. If they put complex in the